let's give this a go. Hopefully the stream info is correct now. Hopefully the sound's okay as well. It's bloody warm in here. Hey guys, you've got here, hey Mr. G, Handy Magic Knight, Steps, Microman, Furroy, Aquafin. Hey guys. Okay, cool. So I added some lights in the background and put all my computers up there. You can only see about half of them actually. It goes all the way up. It goes all the way up there as well, but you can't really see everything up there, so I thought I'd just focus on me and what you can see. Hey ZZ. Go. You need to actually see some of me. So I need to fit more lights. I want to get lights up and down the thing. And I got controls, I can change the colours of them and stuff. It's kind of cool. I was just getting bored at looking at junk behind me, so I thought I might as well tidy it up a bit. Music's still a bit loud. And I'm just on coke tonight, nothing special. Okay, so what I wanted to do tonight was take a look at sprites. We've got the basics of the game running. Remember how to build it. Yeah. So you've got the basic kind of map display and character animation in place. It needs to be a few tweaks to it. I mean, this light is very predictable at the moment. It should be random. So I'm going to look to introduce some more random into the random function, which is there somewhere. Let's put some other here. So yeah, I'll do that at some point when I start thinking about polishing each of the screens, which I will do early on in this game, because it's quite important that the screen layout is pretty good. And the screens are a lot smaller than they are on the C64 as well, so although the map will be very similar, it won't be exactly the same. There will be some differences, just because of the size of the screens. Are about half the width, just over half the width. So what I did today, just to give me a starting point, was I took the sprites from .cosmos 1, just the player sprite up here. So this row basically, excluding the jump, and tried to create a 16-bit version in YHCR. It doesn't look great at the moment because I kind of rushed it. It needs a bit of tidying up, but it should be enough for us to test whether or not the sprites work. I've tested the animation, it looks kind of okay. I had to use an online tool to generate the animation from a sprite sheet. So category Astro Boy. Okay, hang on. Oh yeah, sort that out. There you go. Hopefully that's sorted now. Yeah, category science and tech now. Cool. Okay. So I was a bit bothered about this white flashing on the screen, but apparently that's not a problem on the actual Game Boy Color, because I tried it on the real device. Actually, let me get the device. Kind of needs some power, but hopefully it's enough to run it. Okay, so it's a slightly out-of-date version, but you can see the screen doesn't flash white when it goes to the next screen. So it's something to do with the way the LCD blanks, but so that's what I'm going to go for. I mean, that's what we're going to see. We're not going to see this white flash as it flicks across. Who reads? Has the same processor as the 64? No, not at all. It's a Z80. Oh, I got look at the reflection in the screen. Busted. What reflection? Oh, you mean in the Game Boy screen? So I got this manual. I can't remember who posted. Somebody posted it in Discord. It was available. I've not read through it yet, but it seems pretty good. It's got lots of kind of routines in that you can use. To be honest, I'm more interested in the first half of the book with the tables like that show all the Z80 instruction set, and I realised that a lot of this is not going to be useful on the Game Boy, but it's good to read it anyway, get it all in. So who reads chat? Not Shalan, but he gets work done. I guess he's not distracted by chat. Oh yeah, let's have a look. See what LDIR is in here. I'm guessing it will be. To be honest, I've not even remotely looked at how to look stuff up in here. I'm guessing it's in alphabetical order, which it looks like it is. Yeah. Oh yeah, okay. LDIR, transfer data between memory locations until byte counter is 0. Okay, cool. But unfortunately, we can't use that, so... we are going to use something called OAM DRM today. So I'll explain a little bit about the sprites first. So sprites and game tiles use exactly the same format. Everything's made up of 4x4, 8x8 pixel tiles, which are 2 bits per pixel. Yeah, it's not a Z80. It's some sharp thing, but it's close enough that if you know Z80, I think you can probably get on with it. But the thing is, because I don't know Z80, it's probably slightly easier for me because I won't get distracted by things I can't do. Instead, I'll get distracted by the fact that I have to type 20 times more commands to do the same stuff that I would do in 6502. So yeah, the sprites and the tiles are basically the same. So these are the C64 sprites. They're 24 pixels across by 21 pixels high. They use double width pixels, so it's 2 pixels per bit instead. Sorry, 2 bits per pixel. But not in the same way that the Game Boy does it. Instead, we use 2 bits to represent 1 rectangular pixel. What? No Mario command? Can you guys? I'm pretty sure you can make. Oh, maybe you can't actually. I don't know. Maybe admins can make commands. I'm not sure. Sharp 80 here. Hey Hayes. So yeah, the first task was is deciding how to split these sprites down into 16 by 16 pixels. Now, because they're double wide, that's a fairly simple task to do. And as I say, I need to do a couple of passes on this to get it right, but this kind of will do for now for a walk animation. What I'm more interested in at the moment is just displaying a sprite on the screen. So the Commodore 64 has 8 hardware sprites, which are all this size, 24 by 21. They can be high res or multicolor or a mix of the two. They share, they have 1 unique color each. They share a background color, and if they're in multicolor mode, they share 2 multicolor characters. On the Game Boy, you have 40 sprites. There can only be 10 on one line, and the sprites are 8 by 8 pixels. So to generate sprites this size, you need to use 4 sprites side by side. I think you can have 8 by 16 as well. but I think that uses, I think essentially an 8x16 sprite is just two 8x8 sprites, but where one is more controlled. So I think I don't use Nightbot anymore. I use Streamlabs. I will definitely set a Mario command, but I'll do that in the break actually. It's not a bad idea. Let me make a note to do that because I think we should have one. Because I'm super pleased you've got that out, to be honest. So the first problem we've got is that we need to, for every sprite character we want to draw, we need to draw 4 sprites on the screen. And because you can only have 10 in a line, that means theoretically, if we treat these as 16 by 16 pixel sprites, you can only have 5 of those on a line. Now, luckily, this game is set up, or the C64 game is set up, so that there's only ever 3 enemies, 1 player, 1 key, and any number of doors to fill, well, up to 3 doors. The doors I'm not going to do with sprites. The doors I'm going to do with characters, so that gets rid of that. So that means if we've got a key, 3 enemies and a player, that's 5 sprites. So that's actually perfect. That means we can put them anywhere on the screen and there's not going to be any flickering issues. It means we'll be using 20 of the 40 available sprites, so we'll have 20 sprites left over if we want to do some additional stuff. The other thing to note as well is that the sprites and tile memory share the same area. So let me show you in here. By the way, this is all theoretical. I've not tried any of this yet. It's just from what I've read. So this is our character data in here. I don't know if I can make this bigger. Yeah, I can. There we go. So this is all our character data, and you can see we're doing some animation on it. There is some palette switching going on, which is interesting. I can't remember why there's palette switching because of the flames. That's why. But yeah, this is our tile memory. Now the sprites sit here in this block here, and also can share this block as well. Obviously, I don't want to share this block because I'm going to use this for the characters that you can see on the screen there. But there's enough in this block up here. There's 128 8x8 pixel areas, and I worked out that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 sprites. Which if you times that by 4, because it needs to be built up at 4 8x8 blocks, gives you 108. So there's plenty of room to do that. We don't need to do the enemy move, the player move in the opposite direction, because you can flip sprites, so that's nice and easy. And the old timeline sprites will basically be on here. So on the Game Boy Color, the video RAM is split into 2 banks. You've got the first bank, which is the same bank that the Game Boy original uses, which is this block here. And then on the Game Boy Color, you have an additional bank here. So I'm going to use this additional bank to draw the old timeline tiles and the old timeline sprites here as well, which is nice because it means to switch timelines, we just switch to either bank 0 or bank 1. So it should be nice and easy. And as long as we make sure that the tiles line up exactly to match their new timeline counterparts, things should look great. It also means we can do things like this font here. We can turn this into a proper Commodore 64 font on this side, because I do want to use Petsky on the Game Boy. So it's going to be Petsky, but in Game Boy colors, Game Boy original colors on this side, which will involve some more palette switching as well. So let's go ahead and save the sprite data out from here, trim it down a little bit because it's probably gonna give us way more than we need because it's got all of this crap in it as well. So just trim it down to the block we need to fit it into here, and then I'll try and load it in. So let's do that now. Is this tool a chart to tie to your emulator? This one, yeah. This is a video RAM viewer, yeah. So this lets you see the video RAM, and it lets you know kind of where things are in memory, what tile numbers they are and stuff. I do have an editor, which I actually don't have open at the moment, but I don't need it at the moment either. I was going to add sprite editing to that, but I just haven't had time to do it. To be honest, I've not done any coding outside of the streams or my day-to-day work, so yeah, custom art tools, yeah. Thanks, Andy. Right, okay, so let's give that a try now. Let's close the emulator down. Let's try exporting this. So I think I can just save as... I think I can just save it as that. I think that's enough. And then I'll go and find that in the folders. Well, it's listed under GBA, but it's not. It's Gameboy Color, so... Ooh, why is it showing that folder view? That's horrible. It's better. There we go. I don't know how anybody can have anything but this view on. Hey, Case Padua, welcome to the stream, dude. The music tonight, by the way, is just some random royalty-free 8-bit sounding music from YouTube. Because I'm getting more and more copyright claims. I've been getting it on the Game Boy music as well now, so... And while I don't make any money, I don't want to let the copyright trolls make something, even if it's just a couple of pence. I don't want them to make anything. So I'm going to try and avoid it where I can. And actually, I'm approaching 1,000 subscribers on YouTube, so I will eventually start making money, if only a little bit. Oh, I press pause. Yeah, I get claims for C64 music as well. Quite a lot, actually, for the C64 music. It's kind of insane. And a lot of it is from the same couple of people. Which stinks of kind of copyright trolls, to be honest. But what can you do? The YouTube copyright system is completely broken. So, all right. So I'm just going to take a copy of this just in case I break it. So I'm going to call this backup. Then I'm going to strip this one down in an text editor. So so the file output is 32 kilobytes. That's obviously too big. So what I need is 128 tiles. So 128 tiles, 8 by 8. So that's 8 times 128, which is 1024. So that's 1 kilobyte. So this needs to be 2 kilobytes because it's 2 bits per pixel. So 1024 for one bit, 1024 for the other bit. So if I just scroll down here, I should be able to mark it and then delete from that point on. So that's 1000. And is that right? No, 1000 is not 1 kilobyte. 1000 is 4 kilobytes. So actually it needs to be at 800. So here, so I need to delete from cursor. There we go. Cool. So that gives me a 2 kilobyte file now, which is enough sprites to fit one set of these sprites in. I don't need this. This is a door sprite. I'm not going to use that. Actually, this was a problem on the C64 version. That I was using sprite to sprite collision, which worked fine until I added the vulnerability mechanic, where dock would flash on and off, and the flashing on and off meant that you could just walk through doors. I do have an updated version where he no longer does that, but I'm not going to release that until I release the original music, not remake. Yeah, I'm not going to release that until I release .cosmos 2. So Okay, cool. So it does load straight into here, so I can get rid of this backup now as well. What's Hayes saying? Oh, I was confused. But you just wanted to say my name. Okay, so let's load this into the asset set. So what do we have in here at the moment? So we have tile map up here in this bank. I need to have a look at these banks to see what's going on. Banked assets. Okay, so we've got 3,000 bytes left in this bank to do stuff, so that should be plenty of room to stick another set of tiles and 2 sets of sprites. So they should all go in here, I think. So so they're still called tiles, weirdly, but we can use them for sprites. So I'm just going to call them sprite tiles. Now these are just going to be loaded into a ROM bank, so they need copying into VRAM as well. So if we're going to have a look in, I think it's initialize which does this. Init font called copy font. Okay, where's that? Copy font. I can't remember where everything is. It's been a couple of weeks since I touched this. So what code have we got? Loader. It's probably in loader, isn't it? Copy font. Here we go. So we can probably just copy this entire thing, so and just rewrite it for sprites. Okay, bank fonts. Yep. Pardon me. I'm going to actually add another bank label in here for sprites. Still equal to 1 because we're still in bank 1. It just means that when I read this, it's going to make more sense to me. This load here is writing this value into ROM, and because it's writing into ROM, which obviously it can't do, this is a special kind of command for the Game Boy to switch the bank for loading stuff from the ROM X bank. Say my name. Kissel's vet within it. Oh, what? Oh, I missed that. God damn it. What was Amiga build playing then? Crossout or Turrican, I guess. Freaking hell. I would have liked to watch that. Probably asleep now, I'm like. Copy font first half. So we are going to copy sprites. New style. Turrican's 1 to 3. I don't count Turrican 3 as a Turrican game. Still not played it properly. I keep trying to play it, and when I pick it up and have a go, it just winds me up, so I turn it off. Okay, and our destination is actually 8,000 now. Because the video memory goes from 8,000 to 9,000. Sorry, 8,000 to 8,000. Make the text a tiny bit bigger yet. See, Hayes, if you want to use an IDE which makes all this bigger as well, Visual Studio Code is probably a much better IDE for people to use for coding assembly. Yeah, as I say, the only reason I use Sublime for C64 is just what I had set up, and I've just got so used to it now, so I'm not going to change. Okay, so font tiles instead of font tiles, it's over here. Actually read it. On sprite tiles, IntelliJ or nothing. IntelliJ is so clunky. I hate it. We can use this because this is a local local label to this scope here, if we can really call it scope. Get rid of that because it kind of doesn't make any sense anymore. And then the font second half we don't need, so that should be enough to copy the sprites in. So let's pull that from our initialize. Where is the copy sprites? Yeah. Let's do it in here. I know it says copy fonts, but init fonts, but let's do it in here anyway. I think if we start kind of re-disabling the LCD on and off all the time, it's just going to be a waste of bytes processing power. Okay, so we won't see anything on the screen, but what we should see in VRAM hopefully is our little character up here, and we do, which is cool. So we've loaded that data in here. So the next job is to deal with this OAM. So OAM is the I cannot remember what OAM stands for. Well, basically it's the sprites. I think it's God, what does OAM stand for actually? Let's find out. Doesn't actually tell me. Anybody knows what OAM stands for, please stick it in chat. I'd like to know what it is. It doesn't actually tell me anywhere what it is. It'll be something like object something or other, I'm not sure. No, it doesn't tell me anything about it. Great. But yeah, these are our 40 sprites. So the other annoying thing with the sprites is we can't update any of this data. Same with the screen data. We can only update what's on the screen when it's not being rendered. So remembering the view I had last time, I'm going to do it using this window. If you imagine this is the Game Boy screen. That's a bit annoying. It kind of looks like this. So as this is rendering, there's all this kind of horizontal blank on either side, and there's a V blank area at the bottom. We're going to use the V blank area at the bottom. So once we get down to about this position here, we're going to copy all the data from a copy of the sprites. So we're going to keep a copy of the sprites here in RAM. And we're going to copy that data from RAM into the OAM registers, and there's a special DMA routine to do that. So object attribute memory. Thank you, Andy. Actually, PJ Partridge got there first, so he wins. God, how far behind are you, Andy? I always get the listens from Andy after I've read the stuff, so it's funny. Okay, so let's start by making so we've got our shadow font animations. Let's create a block here for I'm going to just call this shadow OAM, and this needs to be 256 bytes. So I'm just going to fill it with 256 bytes, and basically this is just going to be a copy of this block of memory. So each sprite has 4 attributes. Actually, it needs to be 160, but we're going to fill it with 256 just so it aligns nicely with the page. That music's annoying. Don't like that one. Don't know why. It's grating on me, that one, a bit. Look at I'm on Sunday. Wait, it's not even new. Okay. Yeah, so we've got 40 sprites with 4 bytes for each one, and the bytes define where's the list of what they are? They define a Y location, an X location, a tile number, and some flags. The flags define render priority, i.e. whether it goes in front or behind the background, whether there's X and Y flip, which palette to use, which takes up 4 of those bits. Thank you for the host, Bocus Retro stuff. Thank you very much, dude. And the VRAM bank as well. So by writing 4 bits in here, 4 bytes in here, you can define an entire sprite, which is pretty nice because it's all consecutive numbers. So you'll know from the C64 that your sprite pointers are in screen RAM, so they're kind of off in one place. Your X's and Y's are paired together like this, which is okay, but everything else is not, so it's kind of a bit annoying. Your colours are in one place, and they are kind of, you've got your 3 shared colours, then you've got consecutive colours which are separate from your X and Y's. You don't have an X and Y flip, and your render priority is somewhere else. Plus you have the unfortunate problem of the C64 being 320 pixels wide, so you have to set your 9th bit, if you like. So it's a play option for code like you. Trust me, I'm very much a beginner with this. This is I'm learning as I go with this. Oops. Okay, so I'm going to save that. Shadow OAM. So what I need to do is I need to write some values into this, and then in the interrupt at the bottom of the screen, I need to use the OAM copy, the OAM DRM routine, to transfer everything from this area here into the OAM register. So let's have a look at the interrupt. Let's see what we've got. So we've got a v-blank interrupt here, which sets a frame ready flag when it's finished. So I think we can probably do it in here. So let's give that a shot. Okay, so I'm going to read how to do this at the same time as doing it. So double size or no such attributes. No, there is no double size. There is an 8x16 sprite mode. I don't know how to turn that on, and I'm not going to use it anyway. I'm going to stick with the 8x8 sprites and just use 4 of them. But we do have X and Y flip, which is really good, and the Commodore could have desperately done with that. If you think about every game that's got enemies that face in a direction and can turn backwards and forwards, the majority of Commodore 64 games will have 2 copies of the sprites, one set of sprites facing left, one facing right. There are some games that use sneaky routines to flip them on the fly, but it's quite a slow process. If you've got any kind of game that does stuff at speed, you're not going to be able to do that. So if you're dealing with like multi-directional full color scrolling and huge multiplexers plus character bullets and like a game like Turrican, for instance, would have had to have sprites facing in either direction. But on the Game Boy, we can just flip them, which is really nice. So I only ever have to draw anything facing in one direction, and I can use the flip to flip it the other way. Okay, good night, G12345. Thanks for joining the stream. Okay, so let's do the DMA copy. So DMA means direct memory access. It's a way that systems can very quickly copy stuff into relevant areas of memory. So on the Game Boy, it's used to generally to copy kind of data in the H blank and V blank, specifically for sprites, but can be used for other things, as we saw with the character animations that we did on the last stream. It actually exists on the Commodore 64 as well, but not in the same kind of way that it does on the Game Boy. Anytime you bank in banks from a cartridge, that's a form of DMA. You're essentially loading memory that exists on the cartridge into addressable memory on the Commodore 64, and that's kind of a DMA. Which is why if you've got the 60 meg RAM expansion, that can do some great things, because you can then use 60 meg of DMA RAM to do stuff. Likewise, if you're using a cartridge, you can use the banks on the cartridge to do some clever stuff as well. So in this case, we're just going to use DMA to copy the data from this location to a location where the sprites are, and we do that by first of all loading the accumulator with the upper byte of this. So I'm going to take this, I'm going to do some calculations on it here. So I need to get this, I need to shift it to the right 8 times, and that's going to give me the upper nibble, sorry, not the upper nibble, the upper byte of this. In other words, this is going to be C0, because this is at C00, C1000. So I'm going to write that here. So this is our source. And then we need to store that at, and I'm not going to use the, oh yeah, I am going to use it because we've got these things. So RDMA, which is our DMA transfer and start address. It even says it there in nice letters, and I'm using LDA. So I'm loading this value C0 into RDMA. So that sets up the transfer. Now we need to tell it exactly. Oh, okay, this is interesting. So it looks like they're using a strictly time loop here. So it's 1 microsecond per byte that you copy. So hey Amok, welcome to the stream, dude. In other words, one cycle. And so we need to wait 160 microseconds for this copy to finish. And according to this, the following should take exactly that length of time. So I'm going to type it out, and then I'll tell you what I think is going on. Oops, have we got more than one loop in here? No. In fact, we can use the manual I've just got to check this and see exactly what's going on. So let's put waste 160 microseconds. Now there might be, because I know with the H-Plank there was like a flag to say that it completed. I don't know why that doesn't exist here, but apparently it looks like it doesn't. So I might be wrong though. I might have to have a look and see if I can figure that out at some point. But 160 microseconds is not that long. Is it less than a line? I think it's just less than 1 line. So we're managing to copy all the sprite data in just less than 1 line. So let's have a look at these instructions. So these instructions are repeating 40 times. Oh, interesting. The decrement counter does actually reflect the 0 flag, looking at this. Let's have a look. It doesn't say how many cycles it takes to do though, so it says, it just says subtract 1. I think I need to learn how to read this a little bit more, because it's, oh yeah, it says it does affect the 0 flag. Cool. Which is cool, because things like the load accumulator does not affect the 0 flag. It doesn't say how many cycles it takes, so that's a bit frustrating. I was hoping it might have a list of cycle times for these, but it does not. Oh, it does here on this one. Okay. So what? except these aren't in alphabetical order, so that's kind of annoying. Yeah, I guess so. Yeah, it makes kind of sense. I just find it a little bit weird because I'm used to the C64 version. I don't really know what to expect, but yeah, it kind of makes sense. So yeah, decrease register takes 4 cycles. Now that seems like it's going to take more than 160 milliseconds, but whatever. I'm going to trust what it says in this. So, how many cycles lines do you have? You have 10 lines in the bottom of the screen. But what we're doing with this is we're actually starting a lot of the kind of VBlank stuff at this point here, where the HUD starts, where the lives and power bar starts. Because this never really changes. It doesn't need to animate. There's not going to be any sprites hanging over this area. It's free for us to do what we want in this area, and it's not really going to affect this. So as long as we do it over this side, we actually gain about an extra 6 lines or so worth of time. So that's what we're going to do there. So hopefully now that should just work. We'll just try it. It's not going to do anything. It's just going to, well, I hope it doesn't do anything. But it should just run and not crash. That's the main thing I'm interested in here. She looks like it does. Cool. So now we've got that set up in the RAM. That means we can copy data into here at any point we want, and on the next frame, those sprites will be updated. So the sprite updates will only ever happen at the bottom of the screen. They're not going to happen halfway down the screen, which is a small problem when it comes to the transition, because one of the things that .cosmos does in its transition is it actually creates raster interrupts. It creates 2 raster interrupts. Actually, it creates 3 raster interrupts. 1 at the very top of the screen, and then 2 in the middle of the screen. For the most part, the 2 in the middle of the screen do nothing, and they're exactly in the middle of the screen. And then what happens is when you change timeline, say you're in the old timeline, let's call the old timeline 0 and the new timeline 1. The top raster always sets what the old timeline is. And then as it goes down the screen and it reaches the first of the 2 rasters that are in the middle, it sets the new timeline, so it sets 1, and then the bottom one sets 0. And then every frame, these move apart like so. And so you get timeline 0, timeline 1, timeline 0 again, and you get that kind of fade of the two timelines overriding. And part of that is it changes the character set. It chases the character color data behind, but it also changes the sprite pointers as well. So we're not going to have that kind of the kind of reveal of the sprite in the same way that we do on the C64, but it happens so quickly you probably wouldn't notice it. You'd have to be watching very carefully to spot that it does that. So we will still have the sweep across the screen, but we won't have the sprite changing at the same time. Okay, so let's try setting some basic stuff up in here as well. So let's just do some demo stuff in here. We've already got some demo code in here, which is just switching screens. Let's do some temporary setup here. So let's define a sprite. So if we take a look at our sprite attributes, we need to set the following data: a Y and an X location. So actually, why are none of the sprites show? I would have expected sprites to be shown. Do you have to turn them on somewhere or something? Let's try and set him on. Let's see what happens. So let's just set a location somewhere in the middle of the screen. So the screen is 160 by 160. So if we set 80, for instance, oops, and store that at, oops, God's sake, store that at Sprites Shadow OAM. So and this is going to be Sprite. I'm going to do it like this so it's obvious what's going on. So this is our sprite number 0. I can probably make constants for these at some point, but for now I'm just going to do it like this, just so I can look at it. I'll probably tidy it up later, but I'm going just so I can look at it and understand what's going on. And 0 is the Y location, and we need to put a byte into that location, so we're going to put the accumulator to that. And we'll do the same with the X location. We'll just store the same value there. I can't remember how to copy a line down on this one. There we go. Tile number. Okay, so tile number is actually bring up the no, it's too late. I've got it closed. So tile number is going to start at 0 up here and work its way down. So if we just put 0, we should get that top left chunk of that character, which will be the kind of the back side of his head and the top of his arm, and the flags as well. So I'm going to go with some just basic data for the flags at the moment. VRAM bank, palette number, flip, render. I'm just going to set them all to 0 and see what happens. So I think that should be all right. We probably need to set the pallets in a minute. So okay, let's have a look, see what that does. Hopefully we get something in the middle of the screen. We do. Cool. Okay, so we need to set the palette, but it's definitely there. It looks like it's in front of data, which is good. So we need to look at palette updates. Don't recall any handing color limitations in the conversion. Well, actually, we're less limited in this version than we were in the Commodore 64 version. So the Commodore 64 version obviously only had 16 colors, and it's very limited in that you've only got 2 shared colors and then 1 individual color, whereas on this we've got 8 palettes that we can use for the background and 8 palettes that we can use for the sprites, and each palette has got 4 colors in it, and those 4 colors are chosen from a 15-bit palette of 32,768 colors. So there's quite a lot in there. So it's not really, we're not really handling color limitations as much. What I'm trying to do is enhance the original graphics ever so slightly. Not too much. I need it to look like the original still, but just take advantage of the kind of high res nature of the machine, because it is, you know, the pixels are proper squares, 1 by 1, not 2 by 1 like they were in the multicolor version. Okay, so I'm going to go for a quick break because I need the toilet. And when I come back, in fact, I'm going to set the Mario command up as well while I think about it. After I've been to the toilet, we'll look at how to change the colors of these sprites. We'll get the color set up, and then we'll create a kind of 2 by 2 sprite manager, if you like. So we'll create some dummy sprite objects which you can set, and then it will convert those into actual sprite locations and so on. All right, I'll be back in 5 minutes, guys. Be right back. And I'm back. We'll have a working Mario command now. Go and check it out. It's his first C64 assembly language game, and it's pretty good. It's free to download as well. I don't know if Hayes has done the difficulty update, but I know he was interested in making it a little bit more difficult. So if you want to get some high scores now, would be the time to do it before he fixes it. Okay, let's take a look at palettes. So from what I remember, in fact, let's have a look. There you go. So it's based on the Game & Watch game. In fact, it's a faithful conversion of it. I think this is why he wants to change the difficulty, because it's a bit easier than the the original. And he's done a good job of it. It looks really good. Okay, let's check out the... Actually, it's going to be in our hardware ink, isn't it? So let's have a look in here. Okay, so there are some font palette things here. Background color palette specification. Background color palette. Okay, let's have a look in initialize. It's too bloody hard. So, okay, we do have this routine here, which is setting the palettes. How do we set those? We set those by loading a palette pointer, which is this bit here. And then we call set BG palettes. This seems to be set in FF68, which is background color palette specification. And so we need object, so we need to do the same but with FF6A. I'm going to be a bit cheap and I'm just going to copy this routine. I think we're pretty good on memory. I mean, the original C64 game fit into 16 kilobytes with all the graphics and everything, so I think we can get away with doing this. We just need to change that to F6A. Object color specification, yeah. And this will do exactly the same as the background palettes, but we'll set the sprite palettes instead. So for now, I'm just going to use the same data. Oops. I'm just going to use the background palettes for now to set the sprite palettes, just so we can make sure that they're working. Give that a run. Cool. So we're getting a palette in here. I don't know why it's... Oh, that's the background. Okay, that's fine. Okay, so next job is to actually put some palettes in here. So the palette data is in RGB 15. So I'm going to copy this chunk here. RGB 5, sorry. I'm going to call it Sprite Palettes. And then I'm going to change that to Sprite Palettes. So in RGB 15, it's actually in reverse order. So each color is a block of 5 of these. 5 bits, sorry, for each of the colors. So this is what's in here. So we have an unused bit, and then B5, G5, R5. Now, I believe that this color will be transparent, so it actually really doesn't matter what this color is, because this is our this is the only shared color in all the sprites. Is the background color, so I'm just going to leave that as it is. That theoretically would be white, but we're probably not going to see it as white. So I'm going to try and set 3 colors. So I'm just going to do it 10, 2, 3, 4, 5. So it's a Chiz raid. Hey Tizwicked, thank you for the raid, dude. Welcome to the stream. Thank you for the host chair, Sino, as well. Alright guys, what have you been playing tonight then? Over there. Are you on joystick games? Are you still on the Oh, Chiz got Mario personal best, okay. I have to give Mario a go at the weekend. I warn you that I'm terrible at those sort of games, so I won't be very good. I'm hoping as well that I'll have my Turrican 1 disc by the weekend, then I might give that a shot. Okay, so this is just a little experiment just to see if I can create RGB. So this would be blue as the first color, green as the second color, red as the final color with a white background color, but this will be transparent, so this should get ignored in theory. Okay, that looks perfect. We've got red, we've got green, we've got blue. So let's then go and have a look at our character and see how we need to set this out. So we've got a pink color in here, which if I double click on that, now here we go. I can see it here in RGB 555. So let's start with the red color, which is the skin, which is this one, and let's set that. So this is 1C. So that's oops, 0. I'm gonna keep this on this screen so I can actually see it. 15 out of 350 points. Yeah, Chiz does like to master his games. I've noticed that. He's certainly become a Luma monster, that's for sure. The green is 1-1, so this is 1 here, 3 zeros and a 1. See, if I'd have added my sprite editor to the to my editor, then I wouldn't have had to do this. It's a bit awkward, but 1 3, so this is 1 and then 3. So hopefully that should give us a pink color instead of the red. Pink, perfect. Right, let's do the green, which is this one, which should be the hair, which is like a grey colour. So this is all the same, 0A. So 0A is a 0 there, a 1 there, 0 there, a 1 there, like that. So 0 1 0 1 0 0 1 0 1 0. So it should be the grey hair. Looks like a lemming at the moment, actually. Cool, that's looking good. And let's sort his jumper out as well. So his jumper is also a shade of grey, but it's a much lighter shade of grey. 1A. So actually it's the same as this, but with ones in front of the front of each one. So 1 there, a 1 there, and 1 there. Oops. There we go. Cool. We've got it. So we're displaying one single tile. Actually, should that have a 9? Oh no, it shouldn't have a 9. Okay, that's fine. We're displaying one single tile, and we need to display 4. So not quite 15-bit colors, which is a bit frustrating. But yeah, thank you for the host, Andy. Yeah, the 16th bit is actually unused, so we leave that blank. But they're basically split into RGB like that, with R being the lowest 4, green being the middle, the lowest 5, bits, green being the middle 5, and blue being the upper 5. And as I say, the color 0. So this is BG. Background color, always transparent. So, oh my god, please tell me I've got a case flip. I just want to see if it's there. Selection. No, it's already taken too long. I'm just gonna leave it. What the hell? Doesn't matter. Yeah, difference between 16 and 16 colors. Yeah. Color on the Commodore is 4-bit. So, yeah, 4-bit and not palletized at all. So it's not even like you can change it. You just pick a number from 0 to 15, and that's it. And in fact, in multicolor mode, some of those colors turn into 3-bit colors, and it's to be honest, I like the colors that they selected, but other 8-bit machines did it much better. I mean, if you look at the Atari 2600, it's a very much an inferior machine in many ways to the Commodore, but one thing it excels at is pallets. It's really good with its pallets. It's just you can't do very much with them. The 16-bit is the letter U. I like how Eldritch and Hayes both said that, yeah. And we put this at the end here just to signify that we've reached the end of the color list. This is what is used in this loop here to know that we've reached the end. So somewhere. In fact, where is it used? Is it here? Maybe. If the unused bit is set, then we've hit the end. Yeah. So we always set 0 to these, but then we set the last one. Basically, it was setting the last one to that. But I do it like that, so it stands out as a kind of end of pallets marker. Okay, and the cool thing is on the Commodore 64, we had to share 2 colors, so I used 2 shades of gray to do all the colors, which is kind of why Doc is the color he is, and why he's like that, because there were 2 colors that kind of worked with the rest of it. And we can only change the sprite color, but we can actually change an entire palette, so we can add a lot more detail, I think, to these sprites. 16-bit is you from of course Acmafin had to get in on that joke as well, so red, green, blue. That's 9 bits. 10 if you include the U. I don't know what system you're using. Okay, so I'm going to create a new file now, which is going to be our Sprite Handler. I'm going to actually move some of the Sprite code, the OAM copy into here as well. So I'm just going to call it Sprites. And the job of this file is going to be to put this up here like this. The job of this file is going to be to do a few things. First of all, it's going to do the OAM copy, which we've got in the interrupts down here. So I'm going to move it out of here, which was, where was it? This bit here. And then I can just call but the other job it's going to do is it's going to store it's going to store the information for each of the sprites. So this is going to treat it as 10 sprites that are 16 by 16 characters. So this is what's going to do that work. So we're going to create in RAM somewhere. Actually, I need to import this routine. Let me just import this first. Where should we import it? I don't think it really matters where we import it here. Oops. Should just make sure that works again. Cool. So somewhere I've got a RAM file. Here it is. So I'm going to keep that open. I'm going to keep main open. I'm going to close the assets down. Don't need that. I'm going to close initialize down. Don't need that anymore. I'm going to close HUD down. I'm going to close that down as well. Okay. So we've got the shadow RAM. This is going to contain the 40 sprites we need to copy, which is actually 160 bytes. So I am going to put 160 in here, and then we're going to create meta sprite data, and the meta sprite data is going to be definitions for 16 by 16 sprites. So kind of like we had meta tiles, this is going to contain these, and this is going to have the data for 10 sprites. So the 10 sprites that it needs to put into here are going to be are going to have an X and a Y. So let's just make a list of the data we need. So we need an X and a Y. We don't need flip Y, but we do need flip X. So this can probably be a byte in a list somewhere, so that's fine. It's going to need a Sprite Pointer, which is going to point to there it is. Which is going to point to our sprites in here. I suggest we just point to the top left and have it work out the rest from there. So this is our pointer. Pallet number would be in here. Just going to write how many bytes each one, how many bits each one of this is. So pallet is 4 bits in here. We need to set. What else do we need? Oh, I've lost all my data. Where's all my sprite stuff? I've lost it all. Okay, so X pointer, X, a Y, and a pointer. What else do we need? What else is in the OAM memory? So look. Sprite attribute table. Here we go. That's probably quite a lot. The bank number as well. So this can probably stay the same. Okay, I'm just going to call this attributes because this is actually going to be the same. So actually looking at this, I think we can probably get away with just setting the OAMs for individual sprites and having it update using them instead of using metadata. So basically what we'll do is we'll use the first 20 sprites in here. Is it 20? 10, sorry. So first 10 sprites define top left, and then we'll infer the rest from that as well. So we need a routine in here in that case to we'll call it build sprites. And what this is going to do is it's going to look at the data in here in the first 40 bytes here, and it's going to infer new sprite data. So we'll do it with just the first sprite first, and then we'll loop through and do multiple. So this is going to get a little bit trickier than I've been doing. This is probably the most tricky code I've done today. So let's think about this. When you invert a sprite, the individual sprite reverse it. Yeah, they'll need to be flipped horizontally as well. But that's fine. We can handle that with the with this as well. So when you set a sprite flip position, it will actually position the other sprite on the other side, I think, or something like that. I'll figure it out in a minute. First of all, I just want to get it drawing the 4 pieces around it. So let's load. Let's think about how to do this. So we're going to load HL with shadow OAM. So this is going to load the position of the Y position of our first sprite in here, and then destination will be and this will be plus. Okay, we'll start by doing. How am I going to do this actually? I need to think about this because we can only do addition on the accumulator, so we might have to transfer some stuff around here. Yeah, okay, so I think this is going to be our loop here. We're going to loop back to this point. And we probably need another counter here to count how many sprites we've done. So I'm going to use B for this. I'm going to set it to 10. That's how many sprites we want to copy. So let's start by copying the top right portion. So at this point, we just need to hang on. That needs to be that, doesn't it? And that needs to be something like that. Wait a minute. No, that's right. We need that location. So the first data is the Y register. So all right, we'll do the Y register first. So we're going to load the accumulator with the contents of HL, and we're also going to increment HL so we can start reading the next one. So this is kind of a space saving increment thing. Then we are going to load DE with the location of the next. So we'll work like a book. We'll go top left, top right, bottom left, bottom right. So so the bottom left is plus 80 like that. So then we can load DE got A. But that's going to put two sprites in the same location. So what we need to do is we need to add 8 to the accumulator. That gives us this. That same Y position can also be used. Oh, actually no, because this is only going to work for one sprite. God, I hate the registers on this thing. It's just awkward to think about. Okay, let's do it. Let's do it this way. So we're going to set everything for the next sprite in the top right. So so we're going to increment HL to get the X register. Then we're going to load the value from here and increment. We're going to add A. Whenever we increment HL, we also need to increment DE. These need to be in pairs. I'm going to load the accumulator with the value in HL, which means we also need to increment DE, so we'll increment that there. Add 8 and store that in DE. That's our X register done. Right, let's... Oh, actually, we still need to set the Y, don't we? So actually, we should be doing this. We don't add there, so this is... Okay, right. It's got it now, So this sets the Y. Speed. Yes, so okay, so that sets the Y. Then we're going to set the X. that ink needs to be after as well. I was going to set the X, but I have to add 8 to the X here. Okay, cool. And then the tile pattern number. So the tile pattern number is going to be pretty much the same code, actually. But instead of adding 8, we're just going to add 1 because our tile is just 1 across for this top corner here. And then the attributes will stay the same. We'll work out how to do the flip at a later date. But for now, we'll just copy the attributes over. So that's basically this chunk here. Okay, cool. So that gives us our top right. So we need to do bottom left now. How is this going to work? Because this needs to... It's only going to work for one sprite and then it's going to fail. I'm going to get it working for one sprite and then we can work it out. So, because this thing here is not going to take into account which sprite number we're on. Because here as well. Okay, yeah, I'm going to do this as one thing for now. So let's get rid of this. We'll work out how to loop it in a minute. So bottom left, set the Y. Okay, so the Y does need 8 adding to it. The X does not need 8 adding to it. Tile number needs 16 adding to it, I think. 4, 5, yeah, 16. Okay, so add 16 to the tile number. The attributes stay the same. Okay, and then bottom right. Maybe it's down to how we arrange these sprites. Maybe that's the problem here. Yeah, I think it is to do with that. I think if we, because the way I'm doing it at the moment is I'm using the first 10 sprites as the top left, the next 10 sprites as the top right, and so on. I think they probably need to be in sequence together rather than split out like this. But it's easy enough to change that. We can do that quite easily here. Okay, so bottom right. So bottom right, Y definitely needs 8 adding to it, and X also needs 8 adding to it. Tile number needs 17 adding to it, and attributes stay the same. Okay, it's not RTS, it's T. There we go. Right, so this is just going to do one tile, but I think we can if we just change the format slightly, we can make it work with multiple. So just to test that, if I go into here and do all sprites, hopefully that should be fine. I will move this into actually let's move that down there now. Interrupts. Okay, so we've got the V blank interrupts. Palette switch for bricks. Call it OM copy. I'm just going to do it right here. Should be quick enough that it doesn't affect anything. And we do have the H blank stuff, so I can always maybe move chart and image shadow copy. Actually, yeah, let's move it up there. If it causes a problem, I can move it down. So the LCD stat interrupt is the one that starts in the HUD. So okay, it hasn't drawn anything at all. Okay. Let's put that in main. Just make sure it's actually calling it. Maybe it's not calling it. Shadow animate. Okay, it's not drawing that other sprite for some reason. So let's have a look at the debugger and see what's actually going on. Viewer and viewer. So what I was kind of hoping to see here was this sprite is correct, but I would expect to see for which one would it be? It'd be this one here. And I'm not seeing it at all. Okay, so let's go and have a look again at that piece of code. So there's something wrong in it. So what I'm going to do is I'm going to do it like this instead. So I'm going to load our shadow OAM and shadow OAM plus 4. And then the only thing I need to do here is get rid of these. And on this last one here, don't increment but decrease this 3 times, which is quite inefficient, but I'm going to work a better way out of doing this in a minute. Like that. This whole section probably doesn't need to be there now, but it would do for looping. So okay, still not seeing any information in here. So let's go and have a look at the let's move that code into here. Find out where it is in this list, and then I'll stick a breakpoint in there and have a look. So it is running LCD stat interrupt at 0480. So let's go and have a look at the debugger. I'll find that. It's got to be can go to 480. Okay, that didn't go to 0480 at all, did it? Call 0230. Okay, so 0230 is where our builds were. I could have done that a lot quicker as well. Oh, God's sake. Okay, so this is what should be loaded. Wait, actually, that doesn't look correct at all. No, that's not correct. What was the address? 0480. Okay. Return from interrupt. Oh, it's not saved. We've got a bug somewhere. That's why. Syntax error. Sprites line 16. Okay, so right at the top of the freaking file. So before we even get anywhere, we've made an error. It should be that. That's why. Boom, there we go. We have a sprite. So it was correct. Okay. Interesting. So I noticed there's some glitching going on over here, which means we're probably taking a little bit too long to do things. So I'm going to move call build sprites now into a different location and see if that fixes it. So we do have in this frame ready stuff here. So I'm going to actually do it at the end of the frame ready things. It's still in the intro, but at the end of the frame ready. Because this is just copying into shadow RAM, so hopefully it's the OAM copy has got enough time to do its stuff. No, still getting some glitches on here. Let's have a look at video RAM. Oh yeah, see, we're getting weird data in here now, just for that one sprite for some reason. Which is interesting, because it looks like everything else is copying right. You can see the water looks correct in here. Let's just make that bigger so you can see what's going on. The water is kind of animating correctly. The sprites have been colored properly. They've got the right palettes on them. It's just that animation for some reason is wrong. So let me turn off that port completely and see if it's still broken, because it could be something else is going on here. Okay, it's there is something else going on, and I think what's going on is because we're not using the same place in RAM. So I'm actually going to move Shadow OAM, and I'm going to put it actually put it to 256 again. I think maybe it does need to be on a boundary. I think that's the problem. Yes, that's actually probably what it is, because it needs to be aligned properly. So okay, cool, that looks fine. And now let's go and turn that core build sprites back on again. Cool, awesome. So now what I should be able to do is, by changing the top left sprite, it should change them all. So if I try to changing the sprite pointer to something different, so in this case, if I change it to let's change it to that weird looking one there. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So if I change it to frame 8 in here, so it was in my main, wasn't it? I've got 2 copies of main open. That's confusing. Just close that one down. Which is tile pattern number byte 2. So it's this one here. We should get a different frame, hopefully. Which we do. Cool. So I should, in theory, now be able to change this frame, and it will update. So I'm going to try that by putting in RAM, player frame. I'm just going to reserve 1 byte for that, and I'm going to load that, and I'm going to store that in player frame instead. And then what I'm going to do down here, that's to compare that to, oh, it's Esden again. Stream manager. Hey Esden, welcome back to the stream, dude, and thank you very much for the raid. And thank you to everybody that's come along with Esden. Sort my camera out. I just realised it's just pointing at the top of my head and not much else. How's it been going tonight? What have you been up to tonight? More hardware stuff? We're in the middle of trying to create a kind of meta sprite engine for the Game Boy. Just testing out some, just getting familiar with it, really. I think it's the first time I've used the sprites, so I don't really know how they work yet. You've been doing some more of your FPGA stuff. Okay, so if I keep adding 2 to that, so this is going to be 2, 4, 6, 8, 10, 12. So if it becomes 14, which means if it is not 14, so I go to skip, which is here. Otherwise, load similarly 2 and 1, load player frame accumulator and loads. Okay, so I'm just going to put a little comment in here. Oh yeah, and check out, as Andy's just posted, check out the game that Hayes made on stream recently. He's been working on it for a while now. He's just finished it this week. It's a brilliant port of the Game & Watch game Mario Cement Factory for the C64. Do go over to itch.io and check it out. Get it from itch.io, don't get it from CSDB, unless you want a high score saver. But that's going to come in a later version, right, Hayes? You could just steal the code for the high score saver and just keep that. Just open it up, strip everything out of their intro and just make it press fire immediately, so it just loads the game up, but now you've got a high score saver. And just re-release it. They have no shame in re-releasing their stuff, so in re-releasing other people's stuff, so just steal their stuff. Open up the disk in DIR Master, strip out all their crap, re-release it with a high score saver. Maybe we could do that. It shows the basic screen. I'll say, oh god, are they using the kernel? God, lame. That's just, they've done that because they want to be fast. So rather than actually write their own disk routine, they've just gone the quickest route possible so they can try and beat everybody else to the points. Pathetic, really. Okay, right. Okay, so it's not animating, so it must have an error somewhere, I think, here. Skip, start.skip already defined. Okay. Oh yeah, we're already using it here and here. Oh, God's sake, this is why I like multi-labels. Okay. Well, it's working, just a little bit fast. So I'm going to put a skip 4 in here. And I think we're probably... Is that what this is doing here? No. Do we have a timer? Are we using timers? Temp counter 1, maybe? Or is this in the char animations? Probably a thing on VRAM updates. Okay, yeah, we can use that temp counter. That seems to be what's doing an update in there. So probably need to rename that to something a little bit better. This is only temporary code anyway, so I'm not too fussed about the look of this at the moment. Jump if non-zero to skip 4. Okay, that made no difference whatsoever. Oh, because what I need to do is AND it with AND it with 7. Does AND affect the carry flag? Does AND affect the 0 flag? See, I like this book now. This is actually useful. I would have thought and would do, but it might not do. So it does affect the zero flag. Okay, cool. So I don't need to do that. Okay. Okay. Should we do this? Do this down here. All I want to do is slow the animation down. But it's good because it shows how quick it can actually run it. So flags including bitwise one. Okay, so any arithmetic, any. Okay, so it is fairly close to 6502. It's just that loading a value or transferring a value is not going to set the bit. You actually have to do arithmetic, so you have to actually use bit manipulation of some kind. Okay, that's fine. I can get my head around that now. But it's nice that I've got this manual now because I can very quickly check things. So I definitely recommend this. It's a good book. Actually, Old School Coder's just got the 68,000 one as well. So I wouldn't mind getting a hold of that. Not that I intend on doing anything soon, but well, the music could stop. There we go. Okay, there's lots of temporary code in this, but it's fine. Okay, I don't know why it's not animating that. That's weird. Okay, so let's have a look at maybe this temp counter isn't actually updated like I think it is. Oh no, it's not updating like I think it is at all. It's this frame timer I need. And also, this should be like that. Which means I can put that there like that. Just get that. No. Non-zero. Okay. What am I doing wrong here? Oh, because I'm no longer actually loading that value in. Apron's face. When the music's over, turn out the lights. Let's change the lights. I like the fact I've got coloured lights now. Let's go for red for a bit. Okay. I think that's it now. Cool. I mean, it's not bad. It needs a little bit of work. I think the proportion of his head to his body is a bit off, so I need to shrink his head down a little bit. And the animation, his belt is very static. And one of the things I've learned about particularly 8-bit animation is you should try and move everything a little bit. So, the music's over to. I'm trying to remember what that's from. My knowledge of the Doors is very, very limited. In fact, it probably extends to only. Oh god, I can't remember the name of that. The most famous tune they ever did. Riders on the Storm. That's the one. Jesus Christ, I can't believe I couldn't remember that. Yeah, the lights are crazy. You can do some like stupid stuff. Yeah, that doesn't look too bad. I think it's because it's on slow, but if I put it on like stupid fast. There you go. Just leave it on that for a little bit. It didn't trigger show, that's why I said it. Both wrong. What do you mean both wrong? Okay, cool. So we've got a sprite on the screen. I'm going to take a short break to have a smoke. And actually, I'm gonna get a lemon and lime drink. I think probably not a good idea to drink 2 cans of Coke before I go to bed. Title of the song, I guess, is Riders on the Storm is the one I remember the most. Because it's just a beautiful, beautiful song. It's going through everything. It's going through every single effect now. And there's fucking hundreds, I think. So, okay, cool. I'm going to be back in about 3 or 4 minutes. Probably not even that, actually. It's freezing outside. Right, be right back, guys. Right, I'm back. I did a weird beep then. Let me just replay one of my alerts. I'm not sure what that's. Yep, I've lost my alert noises. Brilliant. Thanks, headphones. Okay, I'll just have to keep an eye on it then. Okay, so that's being called now in here in our build sprites. I think we can start kind of turning this into a proper game loop. So it is called main loop, so that's good. So this bit is definitely needs to stay the same. This is our frame ready flag. Yep, this is the timer that. Yeah, so this is all our frame timer stuff. So this makes sure that this only runs once per frame. And this is our game loop. So everything in here is going to be game loop. I'm just wondering, build sprites is probably not the right thing to put in here. But what we can put in here is controls. So I'm going to add a new file again. Call it controls.asm. Okay, so we need to add a section in. We'll call it controls. And then we need to import it up here. And I have no idea how the controls work, so yeah, I might as well take this headphone out. No point me having it in if it's not working. Lop sync? What do you mean lop sync? Lop sync. No idea what you mean. You just type the same thing. Okay, lip sync. Well, it's not gone for me because I can hear myself fine. So, okay, let's have a look at controls. So I have no idea how to do controls. So let's see if we can find it in this Game Boy Wikipedia thing. Okay, this is just video display, so I want more than that. I want to know. Oh, documentation. It's here apparently instead. Okay, Joypad Input. Here we go. The 8 joystick buttons are arranged in the form of a 2x4 matrix. Select either button or direction keys by writing to this register. Button or direction keys. Okay, so then read out bits 0 to 3. Okay, so this is one single memory, FF00. Okay, so let's just do a very simple player control. We're not gonna do anything other than set the player X and Y. We're not gonna do any jump routines yet. but we're just going to try and get it to move around based on this. So first set FF00 to read direction pad. Okay, so that's easy enough. We can do that with, what was it again? I forgot what it said. Bit 4 in FF00. So we need to load the accumulator with bit 4 set. So that's 2, 3, 4. And store that in, oh, there must be a hardware name for that. What was it? FF00. It's going to be at the top here somewhere, isn't it? It can't be that one, surely. Register for reading joypad info. Okay. Oh, okay. Here we go. So we can use pi F4. Oh god, I'm not going to use that. That's... Oh, get D-pad, get button, get none. Ah, okay, cool. So if we use that, and then use this to read it, well, we have to set. So what, you select either button or direction, then read it out. Okay. No, you're getting audio lag. Drifting in and out. It could be the server. Twitch's servers have been a bit flaky recently, so I know the past couple of streams I've had, they've been a bit kind of funky here and there. So just turn those things off. There we go. It's fine for haze. Okay, so yeah, I'm not sure what's causing that. Okay, so we've now loaded. Now we're reading the D-pad. So what we can do is load. Okay, so it's these things here, P1, F0, and they are completely different to the order that they are on the Commodore 64. So it's right, left, up, down. Okay, so I'm going to put that here. Right, left, up, down. 0 to 3. Okay, so load accumulator with the contents of RE1. You're going to have another routine here called set player sprite. And I'm going to, before I do this, I'm just going to move some code into here. So I'm going to move, actually I'm going to have another one in here called init player sprite as well. Okay. So init player sprite can go in here. This is our init player sprite code here. But instead of it copying into here, I'm going to copy that onto here as well. Oops, did I copy the colon off the end of there? I think it should be that. That should be that. So set the player sprite is going to grab player X, so the byte that's in player X, or player Y for that one, and player X for that one. I was going to grab the value that's in player frame. Where's it? How is it doing that? Oh, because it's done in there. Okay, so player frame, and that needs to be this temporary animating here. Just down to here, like so. Okay, cool. Let's indent this all nice and neat. And this is the attributes, which is just 0 for now. Because the attributes set the time. Yeah, okay, that's fine. So we need to set these 3 values in our initialization. So this would be attributes. Sorry, there we go. So this is going to initialize our player sprite, and this is what's going to actually update our sprite every frame. So init player sprite, set player sprite. So we need to call that in the main loop. We also need to call player control, which is going to actually change those values, right? So hopefully this will just work as it did before, just to make sure everything's working fine. Chipmunk Shalon, really? Ooh, is that not working? Okay, it seems to be fine. Just check there's no errors. There doesn't seem to be any errors. That's good. Okay, cool. So this is all temporary code switching stuff, and that's a loop back to the beginning again. Okay. Am I streaming on Thursday? I don't know yet. I do have a busy day on Thursday, so I might end up being quite tired. I don't know. I might actually take it off and just relax a little bit. So if you want to stream, Chiz, I'd much rather just kick back and watch you. I don't have anything planned for Thursday, so. I could think of anyway. What was I doing last Thursday? I can't remember what I was doing. Oh, I did keyboard control, didn't I, last year? Yeah, no, I think I will. I think I'll take a break on Thursday. So. So I've got a really busy Thursday. Potentially some important stuff to do on Friday as well. So I'd like to keep a nice clear head for that as well. Okay, so I need to read this value. Then I need to. Can we do this by shifting the bits off? I bet we can actually. So let's have a look at the shift. So if we shift stuff to the left, to the right, I will grab these bytes as they come off. So rotate right accumulator through carry before after Actually, I just want to rotate into the carry. I don't want to. I don't want to actually rotate through the carry. Maybe it should be shift right. Actually, it's so. Oh, yeah. That's when your prime sub renews, so I can trigger the sub alert. Okay. No, I think I am going to take the Thursday off thinking about it. I know I'm going to be really tired on Thursday night. I've got a crazy set of deadlines to meet on Thursday. Well, actually, technically, a lot of the deadlines are tomorrow, but it's probably going to be Thursday where it's going to be the problem. And I kind of want to keep my head clear for Friday, so... Can I stream for 5 minutes? Just so Cheers can get his sub renew. I'll be on Saturday, though. On Saturday, I want to add the bar transition in. And hopefully... I mean, I might do something a little bit different on Saturday, depending on how long it takes to... Well, actually, judging by how long it's been taking to do things lately, I think that probably bar transitions is going to take most of my time. But if I've got enough time, I might do some graphical work as well, because I'd like to start thinking about the background stuff. Let me bring up the... RGB DS instruction set. Here we go. I'm gonna look at this instead. I just find it a bit easier to read this list. Okay, so I want to shift left, I think is what I want to do. No, shift right, sorry. Yes, shift right, and it moves it into the accumulator. Is this going to work, or is it going to overwrite this and cause me issues? Oh no, because I've already read it, so... Okay, so shift right accumulator. Is that... How do you do that? Is that... Shift right logical. Okay, so SRL A, like that. And does that set... So that sets the carry flag, so... jump if carry clear, not right. Well, actually, we'll indent this as well. Okay, so right is going to can I just increment a value directly in memory, or do I have to load it first? Let's have a look. I think I might just be able to increment a memory address directly. No, I have to increment byte pointed to by HL. Okay, that's fair enough. So I really don't want to lose the accumulator. So I'm going to load HL with Player X. In that case, I'm going to increase HL. And then shift left again. Jump if carry clear to... Oh. Jeez, got to be here. Otherwise, decrease the value in HL. And then I need to change HL to point to player Y. Then shift again. And this is up, so this is decrease the value of HL. Carry clear. Complete, I guess. Increase HL. Huh, okay. Seems a bit crazy. I'm hoping that it just works with arrow. So, it's a game like this, capitals but small. I think Warlock had done some stuff around that. I don't know. Whichever looks best, basically. John Lem's 12. But I think it probably should be small. No, it should probably be. It should probably be like this. Because I think capitals will make it feel a bit aggressive and not like the lowercase characters look more cutesy, and I think capital letters can look a bit aggressive. So if you look at creatures, for instance, the creatures 2 especially, the font that they use there, it's a massive 2x2 font, but they use all lowercase letters, and so even though it's kind of capital size in the, and kind of spacing and kind of heights and stuff, because they use lowercase characters, it looks a bit more bit more cutesy than it would do if it was all capitals instead. And I bet, yeah, I was gonna say, I bet somebody's mentioned Creatures 3 because I said creatures. I'm figuring you guys out now. Okay, what did it complain about? Let's have a look. It complained about line 12, which is this one. Syntax error. Why is that wrong? Why is that wrong? Yeah, Creatures 3 is definitely the thing that crops up after it long enough. What have I done wrong there? That looks fine to me. Let's have a look. I'm going to stop using that for now, until I've read it properly and I can understand the format that it's in. And instead, I'm going to have a look in here for the jumps. That should be fine. It has to be CC. Is it this? Maybe I don't need to do that. Maybe, let's see. Let's see what happens. Okay, the error is it controls the line 11. Okay, so it is saying that that's an error. Why is that wrong? I don't understand why that would be wrong. Okay, let me just comment that out and see if the next line fails. Is CC not CC? Control 17. No, it's failing on those for some reason. Oh, is it what? Oh, God's sake. Please tell me it's not this. No, because these work. Or is it because I'm using capital letters in here, maybe? You just... Whoa, what the fuck? NC. Really? So I can only check if the carry... Oh, it should be C, not CC. Oh, okay. So it's not clear. Wait, that doesn't... That's... Okay, let's try that, but it looks like it might be wrong. Oh, mind you, no, it's coloured it correctly. Yeah, I think you're right, actually. C for carry, NC for no carry. Okay. Yeah, it seems to have worked. Okay. I mean, the controls are back to front. And there is some weird delay between the sprites updating. Okay. Okay, first of all, let's just reverse the things. Let's make all... Wait, why is decreasing that byte? Are these the wrong way around? Is this left, right, down, up? I think this is the wrong way around. Yeah, this is the wrong way around. So that's actually left, right, down, up. So that needs to be decrease. That needs to be increase. Let's just check that. 10 points in a lolly here. Okay, that seems right. Up and down is wrong now. And you can see the build sprite routine is not keeping up with the control routine as well. So we need to figure out why that's wrong. Maybe we need to link them all together. Actually, it wouldn't hurt us to do that. Actually, if I put build sprites directly after these things here. Actually, we're setting player sprite directly. Oh no, that's fine. Yeah, no, that's fine. Okay. That's better. Okay. So I just need to flip the up and down now. Where was it? Controls. So I need to flip these two. So this becomes down. This becomes up. That becomes up. That becomes increase. That becomes decrease. Let's close the millions of windows I've got open there. Yeah, this is kind of all right now. So the thing I'm going to do now is deal with the direction that the player is facing in. So let's do the flip here as well. Okay, so player facing. Actually, we can deal with the facing through the attributes. because we have a flip attribute in there. Okay, so what we will do is in the controls we will change that flip attribute, so it's going to go all super weird when I do this. Let's duplicate this page. Video display. Sprite Ramberg. No, let's look at this one here. What's the OAM memory? That's what I'm looking for. That's what I'm interested in right here. There's 70 references to OAM in here, so it would be good if there was a nice index into this data somehow. Sprite Ramberg memory map. Fucking hell, where is it? LCD status, LCD interrupts. I need my OAM data. Where is it? Is this it? No. Sprite attribute table. Here we go. So bit 6. No, bit 5 I need to set. So if we're moving left, I need to clear bit 5. Set bit 5 of player attributes. Which I've got to be careful because I'm using. Oh shit! Am I going to do this then? Oh, I need to push, and then there we go. Right, which means I can then load accumulator with the contents of player attributes. And I need to set that byte, so I need to AND the accumulator with, which byte was it again? Bit 5. Okay, so 765. Good if there was a way to do that directly on memory. Hang on, can I do that with? No. Oh, that's annoying. That is a bit annoying, but it's fine. I don't really like having to push onto the stack. I don't know if this is a common pattern in Z80, but I'm not that keen on it. So, okay. And actually, that's not and, that needs to be or. And this needs to be an inverse and, so 2, 0, 1, 2, 3, 4, 5. So, right, so what we should see now is one way the sprite will look correct, the other way it's going to go all weird and gibberish. So correct. And there you can see the sprite flipping to one side. So what we need to do in this case when we move this way is we need to flip those two sprite positions around, or the sprite pointers for those two positions. So we'll do that in our freaking hell, this is going to get confusing, isn't it? We're just doing one sprite right now. Okay, I'm going to try setting a second sprite up just to test this out, because I think we need to fix this routine first. Once I get this routine fixed, I think it's probably quite an easy job that when this is finished, this routine is finished, go through the attribute tables for each of the 10 pairs and just flip those 2 pointers around. So I said tables. Yeah. Trying to think if it's... No, I don't think we need it. We basically just need to... We just need another loop at the end of this. It's fine. Let's get this working properly with the thing. So, okay, so as this goes through, I need to do this 10 times. So I'm going to load B with the value 10. No, it's a good idea, but I think we don't need to do it, and I'm trying to avoid using tables because I think, I mean, obviously they're useful, but the way the Game Boy RAM is set up, it's a little bit annoying to have stuff over here. I'm gonna try and do it just with another loop at the end. I think it will still work. Okay, so just need to make sure that this is advancing correctly. So, so when this is all finished, we are back at... So D has advanced to the right position, but HL is back at the beginning again. So if I get rid of those, I need to add... How much do I need to add? I need to add 12, 13 I need to add to L. So if I load accumulator with L, add 13, load accumulator back into L, and then load accumulator with B. Actually, I can just do decrease B. And then I can do jump if non-zero to that branch instruction is going to be too long, I'm pretty sure, so I don't know, seems to be fine. Everything looks to be good on here. So let's just try adding another sprite in just to test it out. So this is building the sprite. So in theory, if I set a sprite, let's just go into player controls here. Init player sprite. Okay, I'm gonna, maybe this should be called player and not controls. Yeah, let's just change that. So in here, I just want to set these values just for another another sprite, and I'm going to set this to, it's not going to be sprite 0, 1, 2 or 3, it's going to be sprite 4. So hopefully if I run this now, okay, there is another sprite. It's kind of, what is it doing? It's zipping across the screen. Just makes me think there's something wrong in my code. Yeah, there's something weird going on here. I'm not sure what that is. So these 4 are correct, but then these 4 are picking up random data. and they shouldn't be picking up random data. So I'm just going to put set values in here. That's 0, Sprite 0. Okay, so does that Mario command have a limit? No, I don't think so. And this being coded on the CPU. Fixed table in ROM. Yeah, I guess we could do a table in ROM. I need to get all 10 sprites working first, so before I figure that out. Because at the moment this is doing something really odd. I'm not sure what it's doing. You may be over here. It's fine. I don't mind. I don't know where it's updating those values from, but it seems to be doing some strange stuff. I'm pretty convinced this build sprites is not working properly. So let's have a look at what's in these values at this point. So let's have a look for build sprites in here. Just make sure all the code's right. Yeah, it is. Okay, build sprites. Game code. Let's just make this a bit bigger. Funct assets. Okay. It's going to be in this lot somewhere. Sprite routines. Here we go. Build sprites 0485. Okay, let's go and have a look at 0485 and see what the hell's going on. That's alright, I don't mind people downloading that. Good morning, Warlock. Welcome to the stream, dude. Where's my debugger? There's a debugger. There we go. What was it? Oh, fucking, I forgot what it was now. 0485. Okay, so let's go and find that. Okay, so this is the routine when we come into it. So let's run and get to that break. Oh, it's not got to that breakpoint because I didn't put a breakpoint on it. God damn it. Okay. I highlighted it but didn't put a breakpoint on it. There we go. Right. Okay, so we're at that breakpoint. So what I'm interested in is what's going on in these two locations here. So what we should be seeing is shadow OAM, which is at C1000, and shadow OAM plus 4, which would be C1004. And that should copy into. Okay, well, let's step through it and we can see. Okay, so step over first. F3. Okay. Okay, so we've got the right values here. HL gets implemented, some values get set, and these copy along for the sprite. Okay, so that's the first part of the sprite done. Then this should get reset. And this goes up, this goes back down to C0. That's correct, right? Then it does the same thing again. And then it will do it again, go down to 0, and then it will do it again up to C04. Yeah, right. So the new destination is C010, so it's got the correct destination. Accumulator, it's got the 3 from here. We add 0D, which is correct. We store that back in L. The destination is wrong, so we need to add 4 to the destination at the end. That's why it's wrong. So we also need to so we'll do the same thing here, so but we'll do it with E instead. So we'll load E, and we add 4, but we need to add 1 for the bit that's missing up there. Hopefully that fixes it. Oh yeah, I should have maybe mentioned that in the list. There we go. So we can do multiple sprites now. Okay, cool. So Also, he looks a bit fatter in this. I think I need to thin him a little bit. His head's too fat in this one, and he looks a bit too fat in this one as well. So, okay. So all we need to do in that case is when we do the reverse, when there is an X flip, we need to flip some bits around. So I'm going to do that, get this working, then I'm going to call it a night, I think. So do this at the end here. So this is actually setting all the sprites up. And that's doing that correctly now. It's good. And then here I need to now check pointers Y flipped. Actually, do we need to think about this? Okay, so let's load V with 10 again. And let's load HL with what was it called? Shadow area. Okay. So we need to check the attributes. So we're going to actually go start here. This is the attributes for this sprite. Lots of focus creep on that camera, probably low light. Huh? Oh, focus. Yeah, possibly. We'll try upping my room light a little bit. Might help. There we go. Also, I'm moving around a lot as well, which is probably destroying it. Okay, so I've got to be careful here because if I always flip, yeah, this is actually going to be quite tricky. So as Andy says, a table could possibly fix this. But then we're using up memory to store animation tables when the data should be extractable. I know what we can do. Two tables, 8 bytes. Okay. Hang on, I've got an idea here. So if I load the flip data from here, which means I need to then and the accumulator with, and again, I've forgot the bit, was it bit 5, I think? Bit 5, yeah, okay. And then here, if it's not 0, then we're going to jump to face left. And this is face right. Okay. And we'll have done. If we're facing right, then all we need to do is we need to check the position of this sprite against the next sprite. So I need to grab the X position of this sprite, which is byte 1, so I need to go back 2. So I need to ZHL. Node accumulator HL. And then I need to compare that against the next one. Anyone making commit lately? No, I haven't committed lately. It's fine though. It's a completely separate file. So I need to add 4 to HL. So I'm gonna do it like this, and then see how slow it is, and maybe make a change if I need to. The accumulator against the value in HL. Right. Okay. Good night. Cheers. Thanks for joining the stream, dude. And the music's gone off again as well. Video paused. Continue watching. Yes, please. And if so, compare the top one. So this one should be less. So if jump, if carry is clear, to done. Otherwise, what I need to do is I need to swap these two values around. So I'm going to load C with what's in the accumulator now. Load the accumulator with what's in HL. Load HL with what's in C. Can I do that? And load HL with what is in A. Yeah, my problem is I'm going to have to do that table for every single sprite, right? That's the problem. And the problem I've got is if you think of the sprite as an array of like 4 tiles, right? If it's flipped. No, hang on. I think I get what you're saying, actually. I'm doing this way more complicated, aren't I? Yeah, okay. Yeah, I've got it, I think. Alright. Okay, let's get rid of that crap. This will work, but I think this is going to take too much time. Okay, so let's create a light sprite table. And this would be, okay, so this is just going to be offsets for the sprite. So given the Sprite Pointer, oh, player frame is already set there, okay. So this would be 0, 1, 16, 17. You mean like this? That's it, okay, right. So I'm going to store this in, I'm going to call this the Sprite temp index. So I can use BC then, you see. Shit, I forgot if I can use that now. Decrease the pointer to by HL, no. So in case I'm going to accumulator. Wait, what can I do here? Decrement the value in the register by 1. Decrement HL, decrement the register. I can't do. Okay, that's fine. Okay, cool. And yeah, definitely points view on this one. So first thing I actually need to do is I need to grab that directional pointer. So as annoying as this is, actually I can do this like this. If I do +3 and then decrease it at the end. Okay. Okay, so that means down here, this actually needs to add 16. Jump if not carry. No, jump with 0 face right. This is face left. So this would be load BC with so I've had no beer tonight, so that's good. Okay, so now BC contains this table here. So what we need to do is whenever we set the tile number here, well, actually, annoying. This is annoying because the top left is the one that defines it. Solan's alerts is broken. Thank you. Welcome, it's all digital. Thank you for the follow, dude. I'm sure someone just said that as well, actually, and I missed it. Oh, no, yeah, okay, yeah. Yeah, apologies, my, oh, Warlock said it, yeah. Thanks, guys. Yeah, my alerts are working, but I can't hear them because my headphones are shite, so yeah, I'm not being rude. Okay, so the problem here is the top left of the sprite is what defines the rest of the sprites. So actually maybe sprite pointers do need to come from somewhere else. Well, okay, let me get this working with everything except the top left sprite. So let's ignore that one for now. So the first thing I need to do is increment VC. So go to the next position in the table. And then here it would be add the contents of BC and ink BC. Seems like a lot of code, so okay, did we get any errors there? We did get one error. Okay. Oops. A bit bigger, I should have done that. Line 32. So it's going to be the BC thing, isn't it? God damn it. Okay. Oh, because it's not that. I want the actual address, not the contents. I'm trying to load an 8-bit value into a 16-bit address. That's why that failed. Still got an error at line 55 this time. Really need to fix that build so it fails at that point. Okay, so I can't add. Do I have to do that? Let's see if that builds. If it fails at 55 again, then we know, yeah, it still failed at 55. Okay, so can't do that. So I need to add the contents of BC to accumulator. You can only add the contents pointed to by HL. Okay. I think I need to rethink this bit a little bit. I'm going to undo what I've got. I'm going to leave this table stuff here. I'm going to copy it. I'm going to undo until it's gone. Just going to put it in and comment it out. I think I need to rethink this. I think tables is the right way to do it, but I think I need to rethink how this actually works. I think what I actually need is another shadow area. Instead of trying to use the sprite data, I need a separate chunk of data which actually stores at least the pointers for the sprites, and then that way I'm not gonna kind of break anything by doing this, and then it should be a bit easier then, I think. So but it's kind of 12:30 now, so I'm gonna stop. So let me just make sure this is working again and compiling. It is compiling. Okay, so back to where we were before. Yeah, I think what I'm trying to do, I'm trying to be clever, and I'm trying to use the first sprite, the first tile in each sprite, to define the rest. And I think that's probably wrong. I think what I need to do is leave those alone and have another area which I change, and then use that to build the other ones up. And I think it should be a lot easier. Because all I need to really put in there is the sprite pointer, the X, the Y. Well, it will just be a copy of the first 40 bytes of OAM memory. So I could probably utilize there's an extra 96 bytes here that are not being used. So I can just use some of the data here. And then that way there's a bit of copying going on, but it should be all right. And actually we can Actually, no, it can't be a day maker because I have to do some clever stuff as well. It'll be fine. I think this can work. So it should be a little bit neater as well, because at the moment the source and destination are kind of interleaved. If we separate out the source and the destination, there'd be one extra sprite copy that has to happen, but they won't be interleaved, so there'll be a lot less kind of increase and decrement of things. And if we just set the data properly, in the right order in the index stuff, so start with the attribute. So the first thing we do is we read if there is a flip, and if there is a flip, then we set the tables, then we read the X and the Y, then we read or then we read the tile data, then we read the X and the Y. It should work a bit easier, I think, about that. Yeah. All right, so that's what we'll do next time. We'll rewrite that function a little bit. Okay, cool. I'm gonna leave it there then, guys. I'll find someone to raid. Oh, my raid channel is way out of date. It says Chiz is still streaming. It says Esden is still streaming. There we go. Let's raid. Well, what's Chinese Hulk playing? Don't know what that is. What's Thunder Ghost playing? I don't know what that is either. Let's go for let's do Tonda, I think. Okay, cool. Thanks, guys. I am going to take Thursday off, as I said. I think I'm going to be too tired on Thursday, so rather than leave it to the last minute, I'll say now I'm not going to do it. But I will be on Saturday, and we'll continue. So cool. Thanks, guys. Thanks for coming along. Got some done. Figured out sprites a little bit. Do need to rewrite that routine, but it shouldn't be too difficult. All right, take care, guys.